In Chapter 1.2, we're going to take a look at displaying quantitative data with graphs. So the first type of graph we're going to talk about is a dot plot. So just to review, a dot plot is when each value is represented as a dot above its location on a number line. So our first example here, we have a dot plot that tells us the number of children in an American family. So along our number line, we have the number of kids, and we go from 0 to 7 on a number line, and we have dots above the number of children. So we want to know what percent of families has 4 or more children. So the first thing I need to do is figure out how many children there are in American families. So I'm going to count my dots. There's 1 dot above 1 dot above 2. There are 8 dots above 3. There are 7 dots above 4. There are 4 dots above 5 and 1 dot above 6. So I'm going to go ahead and add those together. And we have a total of 22 children. Next, I want to count out the number of families as 4 or more. So that means 4, 5, and 6 I want to add together. So 7 plus 4 plus 1. So we're going to get 12. So then because we're looking for a percent of families, we're going to take 12 over 22, and we're going to get 0.5454 repeating. So if I were to convert that to a percentage, it would be roughly 54.5%. So a little more than half of American families has 4 or more children. So our next question is it unusual to have 6 children in a family? Why or why not? So in this case, we're going to look at where the number of dots we have over 6. And because there is only 1 dot above 6, we would say yes, because only 1 out of 22 families has 6 children. So next we're going to look at center and spread of a distribution. So when we talk about the center of a distribution, it's the value that divides the data in half. So basically we're talking about the median. The center is also the median. It's the middle. Okay. Next, we want to talk about the spread. So the spread is the variability in the data. So another way to think of spread is the range. So you're talking about the smallest to largest values. So in that first example, our spread would have been from 1 to 6, because our smallest number of children in an American family was 1 and our largest was 6. And our range would have covered 6 minus 1, which is 5. Next, we want to talk about outliers, and we're going to go over outliers more in detail in 1.3, but for right now, an outlier is or are values that differ from the overall pattern. So in that first example, we talked about 6 would have been an outlier because most of our values were on 3, 4, and 5 children. So you could say that 1, 2, and 6 were outliers because they were values that differed from the overall pattern of having 3, 4, and 5 children. Next, we're going to take the look at shapes of distributions. So the first one here is symmetric. So a symmetric distribution has the left and right sides are roughly mirror images. So if you want to think of it, kind of follows a bell curve. So it starts low, it goes up, it comes back down. Uniform is all the same height. So symmetric, left and right sides mirror. Okay. Uniform is going to be the same height going across. Okay. We also have skewed left and skewed right. Now, skewed left, you would think that most of the values fall on the left, and that's not actually how it works. You start from the left and you kind of go uphill. So I like to think of skewed left is when your graph goes, if you're going to think of it in terms of like skiing, it goes up the hill. Whereas skewed right, which you would typically think, oh, all the values on the right side. Nope. It starts with all the values on the left and it goes down. So you can think of this as kind of going downhill. So in a skewed left, the outliers lie on the left, and in a skewed right, the outliers lie on the right. I would definitely, if you are struggling with how to remember the different types of distributions, write these little definitions that I have down here as kind of like to help you remember the different types of graphs. Symmetric and uniform are usually pretty easy to distinguish between, but I know skewed left and skewed right, those can be kind of difficult. So try to come up with a way for yourself to remember which direction skewed left and skewed right follow. So next we have some examples. So we have 2 dot plots here for recent scores on a test, and we want to compare this data. So we have our Class A, where out of, it looks like possible 10 points, we have, or who knows, we have someone who scored a 2, a 4, a 5. Majority of people got between a 6 and an 8, and someone got a 9. Whereas the test scores for Class B, we have someone who got a 0. It looks like someone got a 1, a 3, a 4, a few 5s and 6s, some 8s, 9s, and 10s, and like 1 7. So we want to know what the shapes of the distributions are. So it can be kind of helpful to kind of draw what the graph does to kind of compare it to what we have on the previous page. So if I'm looking at the test scores for Class A, it starts low and it goes up. So most of the outliers fall on the left. So I would say that Class A is skewed left. Now for Class B, I do realize that after 6 it goes down a little bit, then comes back up, but for the most part for Class B, the values increase and then they decrease again. So I would say Class B is most closely symmetric. Sometimes you're not going to have one that fits it exactly. You're going to have to find the one that best fits the distribution. And I would say for class B, symmetric is the one that best fits. So the next thing we want to look at is a stem plot. So a stem plot is used for quantitative variables. What we do is we separate each observation into a stem, which is the first part of the number, and a leaf, which is the remaining part. We write the stems in a vertical column, and then we draw a vertical line to the right of the stems, and then each leaf goes to the right of the stem, and we order the leaves if desired, which I am going to do for our example. So we have the scores on a quiz in a statistics class that go from 10 to 25, 12, 13, 14, 20. So if we're trying to figure out what our stems are going to be, if I look, I have a couple scores that are below a 10. I have values that range from 10 to 19. Then I have scores that go from 20 to 29, and then I have something that's a 30. So when I'm trying to think of my stems, I'm going to have 0, 1, 2, and 3. They're going to represent the tens place. Now I'm just going to list the ones place on the other side of that value. And I'm going to do them in order from smallest to largest. So I have 1, 7, and I have 1, 9. So I'm going to put a 7 and then a space and then a 9. Now I want to go through all of the values that are from 10 to 19. So I'm going to cross out values as I do them just to keep track. So if I look, there's 1, 2, there's 2 tens, so I'm going to have 0, 0. Then I'm going to work through 11. And there's 1 11, so we're going to have a 1. Then we go 12, which there is 1 of. And then 13, which there is 1 of. Then 14, which we have 1 of. Then 15, which there are 2. 16, which we don't have. Then 17, which there are 3 of. And then 18, which there are 2 of. And then 19, which there are 2 of. So these are all my stems for 10 through 19. Now I'm going to do the 20s. So I start with 20. And there's 1. Then we do to 21, 22, and then we have 2 25s. A 27 and a 29, and then lastly we have 30. It is always important that you include some sort of key for your dot plot. So you give an example. So 0/7 is a 7 on the quiz. So that's why I know it's a 7 and not a 0.7. So it is important that you have some sort of key for your stem plot so we know what the values represent, especially if they're not already listed somewhere on the page. So lastly, we're going to take a look at a histogram. And a histogram is a graph of the distribution of quantitative variables. So a couple things about a histogram. It is good for quantitative variables. It separates data into what we call classes. So a histogram is going to look very similar to a bar graph, but all of the bars are going to be touching. They're not going to be spread out. And the most important thing about when you separate your data into classes is to have them be equal width so you don't skew the graph. So when we talk about equal width, when we pick our classes, we don't want to go from 1 to 5 and then from 5 to 15. So that way, because then we're changing our class size from 5 values to 10 values, and we're going to get different widths. So I'm going to show you a few different ways to do a histogram. There's a way to do it by hand. There's a way to do it on a graphing calculator. And then lastly, there's a way to do it in Excel. I'm going to do it by hand on here, but I'm also going to tell you the steps on how to do it in a graphing calculator. And then there is a video on Classroom showing you how to do it in Excel. So to start off by doing it for hand, you want to find your classes. So if I look from my smallest value and then my largest value, my smallest value is 100 and my largest value is 135. So I'm going to split my classes into sides of 5. So I'm going to list my classes here. So I'm going to go from 100 to less than 105. And it is important that we distinguish to less than 105 because that means I'm doing 100, 101, 102, 103, and 104. And then my next class, which has to start at the same value, it's going to go to less than 110. And I'm going to keep following this pattern until I get to 135. So then we're going to go from 110 to less than 115, 115 to less than 120, 120 to less than 125, 125 to less than 130, and then lastly 130 to well 130 to less than 135, and then lastly 135 to less than 140. Next, you want to go through and figure out how many of your values fall into these classes. And I went ahead and did this ahead of time to save time because our data does have the record high temperature for each of the 50 states. So there are 50 values here, so it can be a bit time consuming to find the number in each of the classes if you have a large number of values. So going through the numbers that fall into my first class, there are 2 of them. Our second class has 8. Our third class is going to have 18. Our fourth has 13, 7, 1, and then there are 0 that actually fall from 130 to less than 135, and then our value 135. Nope, I have that wrong. There's one value that falls. We have 134, it falls between 130 and less than 135. So I don't actually need this last class 135 to 140 because my largest value is 134. So now I want to construct my histogram. So I have 2 axes, an x and a y-axis. My x-axis is going to be my record high temp, and my y-axis is going to be the number of states. So when I do my scale on the bottom, I'm going to do 100, basically the start of every class. and then the end of the class. So I go from 100 to 135. And then along my y-axis, I'm going to go up by even numbers. So I'm going to go from 2 to 20. So now I actually want to construct the bars. So in my first class, the 100 to 105, I have two states. So I'm going to start at 100 and end at 105, and my bar is going to go up to 2. And I'm going to fill it in. Right. Next, my class that goes from 105 to 110 has 8. So I'm going to take my bar to 105, I'm going to continue it up to 8. I'm going to do the same thing with 110. Okay. And then 110 to 115 has 18. So again, we construct our bars. Then 115 to 120 has 13. So 13 is going to fall in the middle of between two of our lines. $120 to $125 has 7. $125 to $130 has 1. And $130 to $135 also has 1. So this is our histogram that represents the record high temperatures for each of the 50 states. So each bar touches each other. I am going to write the steps here on how to do it on a TI graphing calculator. So this would be a TI 83 or 84 or TI 83 or 84. So the first thing, so your first step is going to be to hit Stat, and then Edit. And under List 1, you want to go through and you want to copy down this table. So you want to take all 50 values and put them into List 1. And make sure you're taking the time to double check the values, because if you make a mistake, you're going to have to go back and double check, and it could take a while. Okay. Then you're going to go to y equals. You want to make sure that plot 1 is highlighted. Okay, and to highlight it, you're just going to go above it and hit enter. Then you're going to hit the second button and then y equals. And then you're going to go into plot 1. And to go into plot 1, you're just going to hit enter. You want to make sure it's on. Your type, you want to have the histogram. So it's going to be the bar graph. And then you want to make sure for X list it says L1. It should do that automatically. The next thing we're going to do is we're going to hit Window. And we want to make sure that our minimum and our maximum follow the minimum maximum from the table. So for me, I did my X min is 100, my X max is 135, and then I had my scale go up by 5. So that way my classes were the same as what we had. For my Y-min, I went from 0 to 20 and had my Y scale as 2, just like we did in our graph. And then lastly, 7, you hit graph. Now, if you were to skip step 6 and went directly from histogram to graph, it would automatically create your windows, and then you'd have to hit zoom and then 9. And again, you only have to do this if you skip step 6, if you don't create your window ahead of time. But then your graph should look exactly like the one we drew, and if you hit trace, you can actually view the minimum, and then the max actually will say less than and then the value, and it tells you how many fall within that range, and it's going to look exactly like the graph we created. Please let me know if you have any problems with doing this on a graphing calculator. I'll be happy to work with you. So the last thing to remember is the number of classes you pick can change the shape of your graph. So if you have a graphing calculator, you can play with this. So if I changed my scale to actually be 10 in the window, and I went back to my graph, it would look completely different than the one we currently have. So picking the size of your classes is extremely important, because if you pick your classes too large, then you don't get as many bars. Okay. So let me know if you have any questions.